Hello, grade 4 students. In this video, we're going to solve our second review worksheet. And in this worksheet, we're going to revise everything required for our final. So let us start with the first question. In the first question, we need to tell if each figure, it's a line, it's a semi-line, or it's a segment. So starting by the first one, this is a line because we have arrows on both sides. That means we can extend it as much as we want. So this is a line. In the second figure, as you can see, this is a segment because it starts in E and ends in F. So this is a segment. In figure 3, this is a semi-line, or we say this is array. So both words tell the same figure. So this is a semi-line because it starts in L and it never ends in the other side. In number 4, this is also a segment because it starts, we have the beginning and the end of the line. So this is a segment. In number 5, as you can see, it starts in M and it never ends in the other side. So this is a semi-line or array. And in figure 6, we have a line because we have arrows on both sides. So let us continue now to question number 2. In question number 2, we already have a figure, and from the figure, we have to pick out all the points. So what are the points that are in the figure? It's point A, it's point B, C, D, E, and F. So those are the points. Now, can you give me any array? So B, E, it's array, and that's how we write array. It starts at B, and it's open on E. And also BC, it's array because it starts at B and never ends at C. Now we have also BA. This is also array. Now any two line segments, you have to know that DF, it's a segment. Also BD, it's a segment. Okay, now how do we name a line in two ways? So AC, it's a line. Also, CA, it's a line. So both of them work out for the same line. Now let us continue to question number 3. We need to tell if the following pair of lines are parallel, perpendicular, or intersecting. So parallel lines, they never meet at all. Perpendicular lines, they are intersecting lines, but they form a right angle or a square corner, and intersecting lines, they meet at one point. They cross out each other in one point. So it's obvious that the first pair are parallel lines because they never meet or they never cross out each other. Figure 2, perpendicular lines because they have square corner. And in number 3, we have intersecting lines. Let us continue, we still have more. So here we have the first figure, they are perpendicular lines, then intersecting lines, and those are parallel lines. Now, we have to tell if the following lines that are indicated by the arrows are parallel, if they are perpendicular or intersecting. So the first pair, as you can see, they have a square corner. So these are perpendicular lines. In figure 2, as you can see, RQ and SP are parallel because they never cross out each other as long as you extend them. Now LM and MN, they are perpendicular lines because they form a square corner. Now WV and XU are parallel because they never meet. EF and EH are perpendicular because they have a square corner. And at last, UT and SV are parallel because they never meet. Okay, now let us continue to question number 5. We need to tell from the figure. Okay, so we have a figure and we need to write the following. Now, what can you tell about EF and AB? Those are parallel lines. Is PQ, I'm going to change the color. Is PQ perpendicular to CD? Yes, they are. Why? Because they form a square corner. So what do we have? A square corner. That's why they are perpendicular. Now they are telling us that CD, I'm going to change the color, CD and MN are intersecting. Is this true? It's true, of course, because they cross out each other. And now the question is, how many lines are parallel to CD? Also, I'm going to change the color. So CD, it's parallel to AB and it's parallel to EF. So how many lines are parallel to CD? 2 lines. Now name any three pairs of intersecting lines. There are a lot of intersecting lines, so you might have more than one answer. I'm just going to give you one, like MN and AB are intersecting, CD and MN, EF and MN. Also, you can say KLPQ. So you have many intersecting lines. You can choose any pair. Now let us go to question number 5. In question number 5, we need to draw two lines AB and CD that are intersecting at O. Of course, I don't have here actually a ruler, so I'm just trying to draw them like AB and CD. This is AB and this is CD. Those are two intersecting lines at O. Now place a point E on AB. So I'm going to choose E here anywhere. Also F on CD. I'm going to choose F here. Now they want you to draw a line which is parallel to EF. So first of all, I'm going to draw EF. So this is EF. They want you to trace another line which is parallel to EF and passing through O. So parallel to EF like this. Of course, when you draw it using a ruler, you'll find it much easier. Now let us continue to question number 6. And in this question, we need to write the Euclidean equation. Let us remember together, how do we write the Euclidean division or the Euclidean equation? So we write 37, it's equal to, we open a bracket, it's 6 times. Now you think of a number, you multiply the 6 by to get 37. It's 6 times 6, which is 36, but we still have 1 as remainder. So that's the Euclidean equation. Now 30 equals, we open a bracket and we put 5 times. 5 times what? It's actually 5 times 6 without any remainder, so plus nothing. 88 divided by 9, so 88 divided by 9, it's 9 times. So you ask yourself, what's the number you multiplied by 9 to get 88? It's actually 9 times 9, which is 81. That means we have 7 as remainder. Now 25, it's equal to 4 times something. It's 4 times 6 because it's 4 times 6, 24. So we have a remainder 1. Now 50 divided by 7, it's 50 equals 7 times something. 7 times 7 is 49, plus 1, it's 50. Now 75, it's equal to 8 times 9, which is 72, plus 3. 20, it's equal to 3 times 6, which is 18, plus 2, it's 20. So that's the Euclidean equation. Now, question number 7, we need to circle the correct Euclidean division. So you may write a lot of Euclidean divisions, but you have to check if it's true. How do you check? 10 times 7, it's 70, plus 3, it's 73. So it works out, but you need to check if the 3 is less than one of those two. So 3, it's less than 7 and less than 10, so that's correct. Now 8 times 9 is 56. If you add 56 with 16, you'll get 88, but 16 is not less than 9, it's not less than the 8. So the remainder, it cannot be less than the divisor, so this is not correct. 8 times 9, it's 72, plus 2 is 74, and 2 is less than 9 and 8, so this is correct. 8 times 11, it's 88, plus 9, it's 97, and the 9 is less than 8, so it works out. 5 times 4, it's 20. 20 plus 2 is 22, and 2 is less than 4, so it works out. 5 times 5, it's 25, plus 2, it's 27. 2 is less than 5, so it works out. Here we go to the last question, which is the Euclidean, the division, and writing the Euclidean form. I'm going to solve the first one. So you do the division, which is 13 divided by 2. Now you ask yourself, what's the number you multiplied by 2 to get 13? It's 6. 2 times 6 is 13. Sorry, it's 12, excuse me. And now you subtract. 13 minus 12 is 1. So what's the Euclidean division? We write 13 equals 2 times 6 plus 1. All the rest are the same. So I just advise you now to stop the video and solve them by your own. And as you know, the solution, it's already found on the Padlet, so you can check the solution. And that's it. Okay, so it's very easy to do them.